Okay, welcome back to the Dublin Academy of Maths. Now it's Michael and it's Leaving Cert Ordinary Level Maths, Series 4, Episode 8, Paper 1, Complex Numbers. Okay, now complex numbers can end up in a quadratic equation. Okay, now because it's real and imaginary, they don't tend to show them on graphs, but they would like you to be able to solve them. Okay, now remember we had this before, we had a quadratic, okay? We had this type, we had a quadratic like this over the x and y axis, and we had another one that was going like that. Okay, so that was a negative quadratic. Negative ax squared plus bx plus c. Okay, so now that they want you to find solutions and all this, so this is all about finding solutions, and using quadratics you can find solutions. Okay, you can find solutions to common mathematical problems. So we had a rule here that we know that the roots of this equation are not going. The roots are going to be real and imaginary because we're on complex numbers. Okay, now how will you know that? Well, you can see that there's a z here and there's a z here. They usually show them as z. Now that's not the only proof. Okay, you get an equation. Say you're given an equation and it says find the real and imaginary roots. For example, z squared plus 4z plus 5. Now it says solve for this. That's all it says, solve. In other words, find the solutions to this. Okay. Now I know I have a formula that I have to use the formula because there's no factors of 5 when added is going to give me the coefficient of the middle term, which is 4. Okay. So I have to well, there's 1 and minus, well no, it's minus plus 5, so all I have is plus and minus this by minus. So what I do is I use my formula, okay? Now you remember the formula, which was z now in this case, because z is the solution, okay, is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now this is the formula you have to use when you're solving equations, and you couldn't get the factors, so you use this formula to find the roots, okay, and then you can work back and find the factors. We did this before in functions. Now so what I'm going to do is I'm going to try and solve this. What I'm going to do is I'm going to solve this equation, so I'm going to put this formula up here so you'll be able to see it. Z is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, and I'm going to get z squared, and I'm going to look at the z squared here now, this equation. So I've got z is equal to z squared plus 4z plus 5 is equal to 0. Now, okay, so now I'm looking at my points. My points are a is equal to, I'm looking at the coefficient of z squared here is 1, coefficient of the middle term is 4, and the c is equal to 5. Okay, so that's the way it's written, A, B, C. Okay, so that's the format. So I put them in, I put my values in. Z is equal to minus b minus 4 plus or minus the square root of b squared, 4 squared, minus 4 times a, which is 1, times c, which is 5. Now you can see this is a large number, minus, all over 2 times a, which is 2 times 1, which is 2. So z is equal to, or the roots are equal to, of this is minus 4 plus or minus the square root of 16 minus 20, okay, all over 2. Just checking that. 16 over minus 20. Okay, right, that's good. Now, because I have a problem here now, okay, well let's clean this up. Okay, so I've got, this is equal to minus 4 over 2 plus or minus the square root of minus 4 over 2. This goes in, minus 2 times, plus or minus. Now I have to do something with this minus 4. You know that minus 4 is going to equal to, minus 4 is going to equal to root minus 4 times root minus 1. That's the whole idea. Okay, you took out the minus. This is a third explanation here, but you took out the minus, okay, from the minus 4, and so you got root, so that's 2 times I. Do you see that? Okay, because square root minus 1 is equal to I, right? So you got 2I here, so you got 2I over 2, okay, so it's I. Okay, so it's minus 2 plus or minus I. Right, let's write this back up again. So the answer is equal to minus 2 plus or minus I. So these now are the roots of the equation, of this equation. So I'm going to put up z is equal to, as I've solved it, minus 2 plus I, or minus 2 minus I. There, or, okay, not multiplied by. So there's the two roots. Okay, minus 2i, plus I and minus. Now you see that there's something going on here. One is the conjugate of the other. Okay, you see the difference is the minus. Now that is a big, that's a big, well, it has worked out that way. So there's only, so this root is the, its other root is this complex root. So if you're only given one root, say for example, you can find the equation. How can you find the equation? By slipping it into the, remember before we had x squared minus x times the sum of the roots plus the product of the roots. We had this before. When you're solving given roots is equal to 0. When we found the roots of a quadratic equation, we put the roots in and we found the original equation. Well, exactly the same can be done with this. We just put in the roots. We found one root, so we can put in its conjugate. So it's 3 plus 4i is a root, so is 3 minus 4i is a root. Okay? So when you're given only roots, so let's do this question back again, and let's see if we can get back and go and do this question again. Okay, get back to the original answer. So there's my given my roots. So if I put them into z squared minus z times the sum of the roots, minus 2 plus I, minus 2 minus I, plus the product of the roots is minus 2 plus I, by minus 2 minus I, all equal to 0. Okay, sorry, I'm running out of space here, but you see what I'm getting at here. So I'm left with z squared minus, so plus I minus I cancels, minus 4 by minus 4 is plus 4. I hope you can see that. So that ends up as minus 4. And when I multiply this out, okay, this is a long equation. This becomes minus 2 by minus 2 minus I, plus I by minus 2 minus I, and you multiply them out and you should get the answer to this is 5. Okay, so you're left with plus plus these product roots plus 5. So you see, you're looking at the top and they're saying, yeah, they are similar. So I'm multiplying minus by minus, and it's plus 4z plus 5. Okay. So we're back to the original equation. So you have proved that the conjugates can give you. So giving one root, you know that the conjugate, if it's an imaginary number, you know that the conjugate is also its root. Okay? And this is a lot to do with the line and the quadratic equations in algebra. Okay, as well. You'll find a lot of it in algebra in series 1, which is free on YouTube. Now, also there was I made an error, but I've already talked about that yet. Well, that's everything now. You know, the next question, the next episode episode 9 is going to be on paper questions. I'm going to do one more paper question for you, and it's going to be free online. And then after that, it's all private. I'll let you know what happens after that. It's just all new videos, modern video up to 2013 and onwards. Okay, the questions. Right, I didn't see the questions. Now, solve each of the following quadratic equations. The same again, so you have to use the formula. Okay, minus b plus or minus. Okay, quite big, some of them are, but get down and do them. Now, if 4i plus I is the root of the equation, find a and b. Well, if 4 plus I is the root, so is its conjugate, 4 minus I. You put them in the equation, z squared minus z times the sum of the roots plus the product of the roots, and you get an equation, and then you be able to identify a and b. Now, not only do they have them in a and b, but they also have them in L and M, so you can get used to different letters, because it's not all uniqueness here, but the logic is, okay? But the letters can change, or the terms can change. Right, that's everything. Thank you.